Hello everyone, welcome to this video. My name is Emerson Ahari, I'm a Google Earth Engine expert. In this video, I'm gonna teach you how to use a statistical operator in the Earth Engine platform. This is a basic tutorial for the beginners. So knowing about the statistical parameters and the statistical operators is a very important thing when you want to deal with the satellite data in the Earth Engine platform, and specifically for the time series analysis. First of all, we must call a satellite data into code editor environment, no matter which kind of data you are using. This tutorial can be worked for all around the world. So go to search places and dataset and type for MODIS NDVI products. As you can see, MODIS per NDVI or vegetation products available with 250 meter or 1 kilometer spatial resolution with different temporal frequencies. 16 days, monthly, and also the daily product is available here. So no matter which kind of data you are using, just important to have MODIS NDVI product. For example, I prefer to use 16-day data with 250 meter spatial resolution because it has higher spatial detail and also the temporal frequency limited to 16 days. In such condition, the satellite data include better quality, high quality pixels. Import it into the code, and as you can see, we have an image collection here. So make a new variable as NDVI equals to, then assigning image collection to the NDVI and filter it based on a period of time, for example, starting from 2023 and ending to 2024. So no need the filter bound for the MODIS data because, as you know, the MODIS has coarse spatial resolution and also it doesn't have framing structures such as we have in the Landsat and Sentinel data. So now just get a print from called NDVI here. In the right panel, 23 NDVI is available. As you can see, we have a one image collection that I have already talked about the image collection format. If you want to know about the image collection and its differences compared to the image format, you can go to that tutorial on my YouTube channel and get more information in this regard. So for each date, we have 12 bands, NDVI and EVI. Both of them are useful for this tutorial, but I prefer to only use NDVI. That's why you must select the NDVI band through the .select function. So if you run a code again, in the right panel, you will see 23 elements, but this time only one band for each date, that it is NDVI. So now I'm gonna show you how you can use different statistical operators to get information from a 1 year using a statistical analysis, some sort of basic statistical analysis. If you want to see or visualize the result, it is better to select a region. For example, I prefer to select Idaho agricultural area that is covered by several farmlands here is available. So if you zoom in on Idaho region in the northwest of United States, here you can see agricultural area easily. Using drawing tools available here, you can draw your study area limited to agricultural regions covered here. So now you can have focus on the study area through the map.center object geometry. The region, the created region already named as a geometry, and whenever the code is running, map.center object allows you to have focus on the border of the geometry or the location of the geometry. So before doing further process, we must go through the pre-processing steps, and meaning that we must check if there is any scale factor for NDVI data or not. Go to the data properties here. You can see the data characteristic in the descriptions and bands. If you go to the bands here, there is a scale factor that should be applied on NDVI data before further processing. So meaning that we must make a loop through the map and also make a new function to apply a scale factor on each NDVI data we have for 2023. So that map allows you to make a loop. Then you must make a function to apply a calculation or computation on each satellite data or NDVI data you have for 2023. So a variable as band we have from each input image IMG. I'm gonna apply the scale factor. Its value was like that. So here you can see. Finally, the function returns the corrected bands with the properties of input images. As I mentioned in the previous tutorials, here in the image collection format, for each image we have properties. The property or metadata explains some information or necessary information about the data for time series analysis. For example, system time start and system time end are some of the most important ones that should be considered for your study because for the time series analysis it is necessary to have them through the copy properties for the output images. So once the NDVI calculated here, now you can save your code and run it again. When you run a code step by step, that allows you to see if there is any problem in the code or not. Again, you will have 23 elements data in which you can see the NDVI values with the properties of with the properties that already copy or get it from the input data. So now I'm gonna show you or make a visual characteristic from the data that we have. So make a new variable as stack equals to get NDVI data, bring all the NDVI data to a band to a single TIFF layer or stack them into a single layer, then clip it based on the region of interest, or you can clip it in the visualization process. Map.add layer here, you can see we have a stack layer that is clipped based on the geometry. Leave the visualization parameters empty for now, and then layer name is NDVI stack, and use the false to avoid automatic visualization that highly reduces the speed of processing. So run a code. After a few moments, so here there is a problem, unable to transform the edge. Sometimes when you are dealing with Sentinel data, you may face with such kind of, when you are dealing with MODIS data, sometimes you may face with such kind of errors for the clipping process or something like that. In that case, you can use, for example, .geometry.bones. First try with .geometry. If it doesn't work, geometry.bones may help. Let's me to remove the geometry or use the bones only. So if the problem still exists, the final solution is a reprojection, because the error you can see in the right panel directly related to the kind of a spatial coordinate system that we have. So here make a new variable inside the loop as the projected equals to bring the bands with the original spatial coordinate system, then reprojected to a new coordinate system. The target coordinate system is EPSG 4326. This is the code that we use for the WGS84, and this value and also this code is the same for all around the world. And a CRS transform, keep it as null, and a scale should be equals to 250. So, and remove the bounds here. And finally, the function return the projected data. The projected data is the data already corrected geometrically and also the radiometrically. Remember to save your code and run it again. So this time there is no problem for now. And if you click on NDVI stack layer, then you can see the NDVI that is clipped based on your region of interest. Go to the layer setting, and here you will see NDVIs that is stacked and available under an image collection. Choose one of them and increase the spatial contrast and click on apply to see the vegetation cover for your region of interest. Yes, now the code is working very well, and now we want to do some sort of statistical operations to see how they work. So there are a lot of time series tools in the Earth engine that allows you to use statistical operators to get a better insight about the situation in your region of interest. For example, if you want to get average from the whole of the year, it is very simple to make a new variable as NDVI mean equals to, you can calculate the average of NDVI for each pixel separately. Just bring the NDVI as an image collection and then through that mean, you will be able to calculate the average NDVI for each pixel separately. So here, finally, you will have NDVI average as NDVI mean that is clipped based on your region of interest. Leave the visualization parameters empty and layer name should be NDVI mean and use the false at the end. Run the code and now you can see the average NDVI for whole of the year. This is the average NDVI, and enhance the contrast using 90% stretch or 90% of values that we have. And every pixel here you can see its values coming from the average that is calculated for that pixel. For example, this is a time series of the selected pixel for a single location that you can see here, and its average calculated through the new variable that you can see here. For another region here, you can see the NDVI variation over 1 year, and also its average value is available here. This is very, very interesting things that helps you to get the average for the time series. And you can repeat such kind of analysis, but this time with different operators. For example, you can calculate the maximum NDVI. Here we will have NDVI max. Just turn it to NDVI max this time. Using map.add layer, you can visualize NDVI max that is clipped based on your region of interest. Again, leave the visualization parameters empty, and here you will have NDVI max and use the false at the end to avoid automatic visualization. Here it is, the NDVI maximum, the maximum vegetation cover experience for each pixel highlighted here very well. And again, if you go to the inspector and click on a pixel, you can see for that pixel the average, the time series, and also the average of that pixel and the minimum value. So the maximum value. So you can do the same for the minimum or median or also other kind of parameters. For example, here it is the NDVI minimum. Just I'm doing to show you how it works. NDVI mean equals to NDVI that mean minimum for each pixel. If you want to get the median value, NDVI median, from NDVI calculate the median image, Or if you want to get a standard deviation, it's a little different technically. NDVI standard deviation equals to get NDVI data, and then through the reducer you will be able to calculate the standard deviation. First engine dot reducer dot st the standard deviation, just like that. Let's visualize standard deviation through the map dot add layer, just like that. NDVI standard deviation already clipped based on the region of interest or geometry. Leave the visualization parameters empty. Here it is, NDVI standard deviation, and use the false at the end. So here in the right panel, you will have the standard deviation, the deviation from a standard value calculated for each pixel here. According to the values we have during a year, for some pixels, higher values, higher deviation from average, and lower values, lower deviation from the average. It is very simple thing. And also you can get export from this image easily, because if you want to bring them into your desktop software, it is very simple to use export function. Export.image.toDrive is a function allows you to save your data in Google Drive, and then you can pick it up from Google Drive and import it into desktop software. Couple of arguments should be considered for exporting process. The first is the image you want to get export with. For example, I'm gonna get export from NDVI median, and the description equals to the output file name could be NDVI median or any other names you prefer, and the scale value equals to 250 because the spatial resolution is 250 meter. And also the region of interest equals to the geometry here, the scale region, and CRS, the coordinate system, equals to EPSG 4326, explaining the coordinate system for the output. You can make a folder in your Google Drive, for example, it is test, or you can pick any other name for your target folder to save your data in. So save your code and run it again. After a few moments, in the right panel under the task, you will have NDVI median value, and as you can see, the run button is available here. Just click on run and run it again. The process of saving is started, and once the tab's color turns to the blue like this one, meaning that the process of saving is over, and then you can pick it up from the Google Drive. So this is the process that you must do, or you must follow for getting export from data in the Google Earth Engine platform. So, and sometimes you may want, for example, to calculate the minimum value for the image or the maximum value for the image. It is also a very simple technique. Imagine that we already calculate the median image. As you can see, the median is something like the average, but it is not affected from extreme high or extreme value during the time period. When you are dealing with satellite data analysis, the median is very helpful because it reduces the noise in the average image that we may have in the final results. So imagine that we have an NDVI value that its average calculated for each pixel separately, and now I'm gonna get the minimum and maximum or the average of one single image. And for example, I'm gonna have a single value that shows the minimum value that or shows the maximum value or shows the average of whole image. Instead of having an image with a grid structure, I'm gonna have a single value explaining the statistical values in an image, where, for example, whether it is the minimum or maximum or any other statistical operators. Here, in that case, for region of interest, I'm gonna get the NDVI from NDVI median, I'm gonna get the minimum value. Bring NDVI median first, and then use the reducer. Dot reduce Earth Engine dot reducer. Here it is. Sorry. Dot reduce Earth Engine dot reduce. It must be reduced region. Yes. The reduced region allows you to calculate a statistical parameter based on region of interest. For example, you want to get the average for the whole region, minimum for the whole region, or etc. Couple of arguments we have here. One of them is the reducer. The reducer is actually the operator that allows us to apply statistical parameters such as minimum, maximum, standard deviation in this scenario. So the reducer or a statistical operator equals to Earth Engine. From reducer dot, you can get the minimum value, you can get the maximum value, or the average value. So for example, here we want to get the minimum value for the region of interest. Geometry equals to the geometry, and a scale is 250. So print NDVI, the minimum value in NDVI median. In the right panel, you will have a dictionary. The output type is has a dictionary format, as you can see, that shows the minimum value detected in this image. So it has dictionary format, but you can convert it from dictionary to a number structure. Just turn it to the values, extract its values, and then get the first item here as 0 and convert it to a number through the Earth Engine number. In that case, you will have only one number instead of having an object. So you can use the same scenario to get the maximum, minimum, or the average for the whole of the data. Here, just print, let me to add a message here. This is NDVI minimum for the whole of the image. And now I'm gonna use this code to calculate the maximum and the median and also the mean of whole image. So here again, this time we want to have the maximum value, Earth Engine reducer max, and you can print the results just like that. NDVI max for the median image, and I'm gonna get, for example, minimum, maximum, or you can have the or you can use any other statistical operators such as average to get the average for the whole of the area. If you want to get more information about the reducer, just go to the docs, and here you can find the Earth Engine reducers. Yes, here it is. Different types of reducers are available, and you can use them to get more information about the kind of data, more statistical information about the kind of data you are using actually. So here the average value can be calculated like that. So NDVI median mean. This time we will have the NDVI average. As you can see, the minimum, maximum, and also the average value calculated for the whole of the area. And also you can have the standard deviation just like that, same as the previous techniques I mentioned earlier. Or here we want to have the standard deviation, NDVI, standard deviation. Run a code, and there it is. As you can see, the standard deviation for the whole of image also calculated. So it was a brief introduction about the statistical operator that necessary to know before further processing in the Google Earth Engine platform. This tutorial only useful for beginner users, and also I will share more tutorial for the beginners who want to get expert in the Earth Engine platform. Feel free to reach me out on my YouTube channel and put your comments there. I will check the questions and answer them as soon as possible. Thank you for your attention.